Welcome to this explainer. If you're into engineering or designing the cities of tomorrow, it's incredibly easy to just look at the ground as this passive, flat surface waiting for a slab of concrete. But today, we're going to completely flip that perspective. We're looking at land not as some empty canvas, but as a dynamic, living, breathing system that literally sustains our entire civilization. By the time we wrap up, you'll see exactly why the health of the ground beneath our feet is absolutely one of the most critical engineering challenges of our time.
Here's our roadmap for this session. We'll define what land actually is, unpack the concept of land degradation, and examine its massive global impact. Then we'll categorize the human causes before exploring some sustainable engineering solutions, and finally wrap it all up with a quick summary.
Section 1. Foundation. What is land?
Before we can talk about the land getting sick, we've got to stop thinking of it as just dirt. I want you to think of the Earth like a highly complex layer cake. When I say land, I'm talking about a fully integrated system. That top layer, the topsoil, it's basically a bustling metropolis of minerals, organic matter, and billions of microbes. And it is incredibly precious. It takes nature thousands of years to form just a few centimeters of it, but we can destroy it in a fraction of a lifetime. Underneath that, we've got the subsoil and bedrock handling drainage. And up top, the vegetation holding it all together like structural rebar. It's not just a physical foundation, it's a living factory.
Section 2. Understanding land degradation.
So what actually happens when this intricate layer cake starts failing? Well, think about your smartphone. You unbox it and it's pristine, right? Super fast, battery lasts all day. That's its peak, healthy state. But a few years down the line, the screen's cracked, it lags, and it dies in 2 hours. That decline in utility and capacity is exactly what we mean by degradation. When our natural layer cake degrades, the land essentially loses its charge, its nutrients, its structure, and its ability to sustain life.
Formally speaking, land degradation is the process where the health, quality, and productive capacity of the land system declines. But here's the absolute kicker. It's accelerated by human activity. We're not talking about some slow, natural geological shift over millions of years. This is a rapid, human-driven sickness where soil is stripped of nutrients, vegetation dies away, and the land simply forgets how to function.
Section 3. The global impact.
So why should you, as future builders and problem solvers, care about this? Let's look at a pretty terrifying number. 10 billion. That's the UN's estimate for the global population by 2050. Now remember, almost all of our food comes directly from that topsoil we talked about, but a massive chunk of our global agricultural land is already degraded. Sick land means plummeting crop yields. We're facing a reality where we have to feed billions more people while literally destroying the factory floor we need to grow that food. It's a direct threat to global food security.
And it's a massive environmental crisis, too. Healthy land acts like a giant natural sponge. It absorbs heavy rain, recharges our aquifers, filters out pollutants, and securely stores carbon. But degraded land, it completely loses that superpower. Water just runs right off the surface, which causes catastrophic flash floods in some areas and devastating droughts in others. Plus, it releases all that stored carbon right back into the atmosphere and destroys habitats along the way. For you engineers, the land you choose to pave over directly impacts this fragile balance.
Section 4. Human causes of degradation.
Okay, let's get highly practical. How are we actually causing this system to collapse? The biggest culprit is unsustainable agriculture. Deforestation rips out the roots that anchor the soil in place. Overgrazing by livestock compacts the ground so much that rain just washes the top layer away. Then there's monoculture, growing the exact same crop year after year, which totally exhausts specific nutrients. And if engineers design poor irrigation systems in dry areas without drainage, the water evaporates, leaves salts behind, and boom, you've got salinization. The land literally becomes too salty to grow anything.
Next up, urbanization and industrialization. As our cities sprawl outward, we do something called land sealing. We literally bury our natural capital under layers of impermeable concrete and asphalt. The land can't breathe and it can't absorb water. On top of that, industrial pollution from factories contaminates whatever soil is left with toxic chemicals and heavy metals. And let's not forget mining and quarrying, which scrape away that precious topsoil entirely, leaving behind these barren craters that are insanely difficult to fix.
The third major driver is our waste and pollution. Dumping solid, non-biodegradable waste introduces tons of plastics into the environment. Over time, those break down into microplastics that deeply contaminate the soil and water systems. Combine that with the chemical pollution from overusing synthetic fertilizers and harsh pesticides, and we're actively killing off those beneficial microscopic organisms living in the topsoil.
Section 5. Sustainable Engineering Solutions.
Now, I know that all sounds pretty grim, but this explainer is really about empowerment. I want to share a quote from Dr. Arun that perfectly nails our core philosophy today. Sustainability is not about stopping development. It's about smart development. As professionals and future builders, your job isn't to halt human progress. It's to realize that we're an active part of this ecosystem, and we need to design our modern world to work with the land, not against it.
And the really cool part is how practical these solutions are. Step 1 is green infrastructure. Instead of just pouring more concrete drains, smart engineers are designing constructed wetlands that naturally absorb and filter stormwater. Step 2 is soil conservation. This means minimizing disturbance during construction, saving existing trees, and designing smarter irrigation to stop that salinization we talked about earlier. And step 3 is urban planning, designing compact, highly efficient cities that don't need to pave over fertile farmland to function. It's all about balance and smart waste management.
Section 6. Summary and final thought. Let's quickly wrap up what we've covered today. Remember the layer cake? Land is way more than just dirt. It's a complex, integrated system that supports life. Land degradation is a human-accelerated crisis that's actively threatening our global food supply and destroying our environment's ability to regulate water and carbon. But the most important takeaway? Engineers, planners, and problem solvers are the key. You have the power to design solutions that aren't just functional, but actually sustainable and regenerative. I want to leave you with a quick perspective-shifting assignment. When you walk around your neighborhood today, I want you to look at the ground completely differently. Seriously, stop seeing it as just a passive surface. Look for the history of the soil beneath your feet. Can you spot signs of land sealing or erosion or poor drainage? Notice the difference between a patch of soil that's genuinely thriving and one that's struggling. The solutions to our biggest global challenges start with how we perceive the very foundation we stand on. Thanks for joining me for this explainer, and keep observing the world around you.